Okay, let's get started. So today we'll talk about list.
Yeah.
What is a list? List is a collection. Okay, collection means it can have more than one value. Okay, so if you ask me how, so let's say I define a list. I call it as L1, and L1 will have values like let's say 21. Hello. Okay. You can have true, okay. You can have whatever, right? You can have complex, you can have Boolean. All these values are allowed. Okay, so L1 has become a collection of 4 values here. And how do you know it's a
Mm.
list? You know it is a list because it has a square bracket. We have seen square bracket last time as well. Why was square bracket used? Square bracket was used for indexing,
Indexing.
correct?
Yeah. Yeah.
So how do you know that this is not an indexing, but it says list?
It has commas.
It has commas, but it can have a single value also, right? It can have a bracket of 2 or
Yeah.
21. In this case, we can have only 1 or 21. See, when you're doing indexing, you will have variable name and then the list. When I put something like this, that means it is a indexing. But when you have square bracket independent,
Okay.
that means it is
It's a
a
list.
list. Yes. You can have an empty list as well. You can have an empty list. I can call it as L1 equal to only square bracket. If you say print type of L1 and when you run it, okay, you get list. Okay. So this is about working with the list. Now, what you see here is um, list can have only one dimensional, or we call it as linear. Okay. Linear collection. Okay. So list is a linear collection and the position of 21 is
0.
0. Yes. Hello is
1.
1. So if I say print L1 of -1, L1 square bracket. I told you indexing is always square bracket.
Yeah.
Doesn't matter it is string or whatever. Okay, it is always square bracket. Now you tell me if I create a square bracket -1, what is the value of, what is the value of L1 of -1?
5.4.
5.4, right? So that
Yeah.
means it is automatically, it has got order also, right? Which is 0, 1, 2, right? So that's why, okay, we call this as linear ordered collection. Okay.
Uh,
So it is linear because it is one dimensional. Okay. It is ordered because, okay, the elements, when you add them in a list, it takes its position. It takes its position seriously, right? So,
mhm.
so when you want to add something at first position, you cannot add anywhere. You have to add it at first position. Only then it will come to know that it is for
Mm.
first position,
Okay.
right?
Yeah.
Okay, so that's what we call it as a linear ordered collection. Okay, now indexing is exactly say as, so I'm not going to repeat it. Print of -1 will give you last element. Print of L1 of 1:3 will give you element 1
Element.
and 2. So you should get hello and true, right? You get
Mhm.
hello and true. You can have a list within a list. So I can say L1 equal to, so last element, okay, is 0, 1, 2, 3, right?
Mhm.
So the size, okay, size of the list equal to len of L1. Okay, so when you say len of L1, you get 4, right? So the position of last one is 3, 0, 1, 2, 3. And you cannot change, I cannot increase it. I cannot say len1 of 4. The moment I say L1 of 4, L1 of 4 will give me error because it has only 3 elements, right?
Yeah.
But you can change the value. I want to add, or I want to change 5.4 to a list of values. So I can say here L1 of -1 or 3 equal to, I'll put a list here. I can say 5.4, 6.9, 8.0, I can add multiple values. The moment you say list, it can add multiple values. Now, if you print L1, from beginning till the end, so you see, you get 21 hello true, and this entire thing as a list is added here. So list can have list, and you can edit the value of the list. I can say L1 of this was not possible in string.
Yeah.
You cannot take an element position and delete it. But here you can, and that's what we say here, that it is a mutable. Your strings are immutable. Your strings are immutable, but lists are mutable. It's a mutable linear ordered collection. That's what list is. Okay. And as I said, you can add the element. Okay. It is mutable, so you can keep on adding element. Okay. And we'll talk about how to add, because we'll talk about functions just like we had functions in string. We'll have functions here also. We'll see that. But before that, let's understand few other properties. So you can iterate through list. So for loop, when we are doing loops, we did only with range. Then later, we in strings also we saw that you can iterate through a string, isn't it?
Yeah.
Now you
Yeah.
can iterate through list as well. So if this is the list, I can say for I in L1. For I in L1, print I. For I in L1, print I. Okay. So for I in L1, print I. Right? Now when I run it, you see, okay, let me put something like this here. Print iterating over a list. And let's say here, iterating over a list, done. That means whatever is between these two statements are from for loop. So you see here, iterating over a list, 21 hello true, and then this entire thing is one value. Okay. Now in this case, since the last element is a list, I can even say, print L1 of -1. Now when I say L1 of -1, you get entire this thing, correct?
Yeah.
Now
Yes.
L1 of -1, and I can say here 1. You see this, you can replace this with A, let's say. I can say A equal to this. And then what is, so A equal to this means this is what is A, right?
Yeah.
This is another list. So now if I say A of 1, what will you get? You will get 6.9,
Oh yeah.
right? 6.9, right? So remember here, each element, retains its own property. So again, if I say type of, print type of first element. Okay, so type of first element will be type of L1, sorry, type is a function. So type of L1 of 0. Now when I say type of L1 of 0, L1 of 0 is going to be your first element 21. I'm asking the data type of 21, which is integer.
Yeah.
So what I say is, this is like a team, when you
Mhm.
make a team of 5 people. Individually, they are different, isn't it? Individually, they have their own strength. Individually, they are different, they have their own strength. Okay. But when you combine them together, when you bring them as together as a team, then they get different power, superpower, right? So, same thing with the list. Individually, they are integer, float, string, or in this case, it is individually also it's a list. But when you put them together under square bracket, they become list. Okay. So
Yeah.
they are not losing their individual identities. They are not
Mm.
losing their individual identities, but together they get more power, right?
Okay.
Together they get more power, which is
Which is
which is the your um, which is your power of string or properties of list, not
yeah.
string, list, right? Talking about list, right? So you get
Yeah.
power of or the properties of list. You inherit the properties of list. What are the properties of list? Properties of list. Okay. So now
Mhm.
we'll talk about properties that are related to list. The first thing is you can add two lists together. Okay. You cannot add, see, you can add two integer together. And we have
Okay.
seen that we can add two string together, right? When you add two string together, it becomes one single string, correct? Similarly,
Yes.
if I say L2 equal to 4, comma 5, comma 6, and if I say L3 equal to, A, comma B, comma C, your print, or I can say L4 equal to
L,
L2 plus
L,
L3, and when you print L4, you get 4, 5, 6 ABC, because we added 2 and 3, and 2 is on the left side. So values of 2 will be added together and followed by the values of 3. So when you add them, you get something like this.
okay.
Okay. So this is how you add two lists together. Now
Okay.
you can add, or you can multiply. So if I say L2, or let me put like L5 here.
Mm.
L5 equal to L4 into 3. Now when I say L4 into 3, okay, L4 is,
L2 plus L3.
yes, 4, 5, 6 ABC. Then I'm multiplying with 3. So you get 4, 5, 6 ABC, 4, 5, 6 ABC, 4, 5, 6 ABC, right?
Okay.
Just like string, it got multiplied, and the values in the list will get multiplied by that many numbers.
Yeah.
Okay. So this is how you can multiply a list, right?
Yeah.
So yeah, with this basic, now let's get into the methods that we have. So methods of list here. So how do I get the methods of list? We'll use L2 only. Okay, we'll use L2 and we'll see. Okay, let me copy and paste here. So how do I access the methods of list?
Mhm. L2 dot. Yes.
Dot, yes, L2 dot, and then you get these M methods. Count and value. Count value will tell you how many values are getting repeated in that. Then
Yeah.
index, very similar to string. Index, see, count and index we have in string also, and they do exactly the same work. Okay,
Okay.
so index also has the value and string start and stop. Value, start and stop. Okay, so you give the value and you give start and stop. It will tell you within that start and stop how many times it is repeating,
Okay.
right? So if I say here 4, 5, 6, 5, 6, okay, and 6, let's say. Now when I say count and I say 5, okay, print count of 5. You see this? You get 2.
Yeah.
Okay.
Yeah.
Similarly, okay, if you okay, L2 dot index. I want the index, position number. Okay. So
Mhm.
if I say index of 5, okay,
1,
or
2, 3.
6, let's say.
Okay.
Index of 6. Not count. Okay,
Okay.
index. So if I say index, index
Mhm.
of 6. So what is the position? Where is it found? So right now, if I ask something like 7, okay, you'll get error
Yeah.
because it is not there. Exit code 1 error.
Mm-hmm.
Okay, 7 not in the list. Correct? So
Mm-hmm.
first you have to find if 7 is in the list or not.
Mm-hmm.
Okay, you can check the count. If count is more than 0, only then you'll perform index.
Okay.
Okay, so if I say something like search val equal to 7, and I'll say if, okay, L2 dot count of search val, okay, is greater than 0, then
Mm-hmm.
you perform index. Otherwise, there is no need to perform index.
Okay.
Okay, now when you run it, okay, you see, okay, 7, right? Okay, so 7 is not there, so we don't get anything because this condition becomes false. Now, if I make it as 6, okay, then you will get 0, 1, 2 because position of first 6 is 2, right? Now, you need to find position of second one. If you need to find the position of second one, okay,
Mm-hmm.
then you need to give something called as start and stop, right? So I
Yeah.
want it to start thinking from 3 to 5, let's say. If I say 3 to 5, okay, so
2.
no, wait, 0, 1, 2, 3, correct? So this
Yeah.
is 3, and then 3 to 5, I say 3, 4, 5, right? But it's still count of 2 is 2, right? But here, okay, you are not getting any value, correct? This is count, right? Else I can say print something is wrong. Okay, now let's run it. Something is wrong. Why something is wrong? I used L1, not L2. You see that mistake?
Yeah.
Okay, I don't know how that happened. Okay, so see, index is 4. I said from 3 to 5. So 0, 1, 2 is gone. This is
Mm-hmm.
3, 4, 5. In 3, 4, 5, the first position again is
5.
position 4, right? After 5,
Yeah. Yeah.
position
Yeah.
4. Okay,
Yeah.
so that's why you got index 4 here.
Okay.
All right. So this is how your count and index work, which is very similar to, okay, what we've
String.
been doing so far. Yeah, string.
Yeah.
Now, now let's look at few more functions. Okay. Now, how do you add an element to existing list? Okay, so I will say L2 equal to 4, 5, 6. L2 equal to 4, 5, 6. Now I want to add to L2.
Mm-hmm.
Okay, I want to add to L2. Now, how do I add to L2?
Create a list within the list.
Create, okay, now, so using programmatically, you have a method called as append and insert. Okay, append function will add at the end of the list. Okay, and insert to add at any given position. Okay, so I want to add, let's say 10 at the end of the list. So at the end of the list, I'll say print. Okay, no, before print, I'll do L2 dot append.
Append. Yeah.
Okay, and I'll say 10.
10.
Okay, L2. Now, when you print L2, see 10 got added at the end. So
Yeah.
append function will add at the end. Again, if I say 10, append 10, and then I'll say append 20, let's say. So now here 10 was the last element, here 20 became the last element.
Yeah.
So when you print it, you get 10 and then you get 20 here.
Okay.
Now let's say I want to add 8 at second position. That means index 1. I want 8 to be at index 2. So L2 dot insert. So insert takes index and the object. Index means where do you want to add, which index you want it to be, and object is the value that you want to add. So I said I want to add 8 at second position. Second position means index 1 and value 8. Correct? So now
Yeah.
when you print L2 and when you run it, so you see 8 got added at the second position
Okay.
and everything else moved,
Yeah.
right? So if you're adding at second position, up to first position, there is no change, correct? So first position is as it is. Second position became your 8. And then everything else just moved on by one value.
Yeah.
All right. So this is how your insert and append works. I want to insert again. Let's say I want to insert as 3 as second position. I will again say 1, 3. When I say 1, 3, okay, so latest is 3 at second position, correct? Everything else, including 8, will move one step forward.
Okay.
Okay, so this is about your adding elements to a existing list. So you have an element and you keep adding to the existing list. Now, I want you to do a program here, okay? Or I will show you tomorrow how to do it if you can. Write a program to input marks of 5 students in 5 subjects and save them as list of marks. Okay,
As a list of marks.
sorry.
Okay, nothing. Yeah, got it. I'll
Okay,
try.
yes. So you have 5 students. Each student has marks in 5 subjects. So you have 25 marks, right? But I want to save as one single list. Okay, so you'll only have marks. Okay, so
So one
so
list for
this
each
is how it
student.
will look like. Okay, so let me finish it, then I'll take your question. So this will look something like this: one big list. Okay, inside this you will have 5 lists.
Okay.
1, 2, 3, 4, 5, and inside each you have marks. Like 1, 2, 3, 4, 5. That means these are marks of one student, correct? These are marks of second student. This is for third, for fourth, and for fifth. Something like this. Okay, here you'll be using append. So using append and double for loop. That's a hint. Use nested loop, one outer loop for students, inner loop for marks, and then the inner loop will also read the value and keep appending to a list. So you will have that. Okay. Okay. Now, how do I remove an element? Okay, I want to remove it. Okay, I don't want it and I want to remove the elements. Then how do I remove the element? Okay, to remove element, again, you have couple of functions, okay, or methods rather, right? So what are the methods here? So methods, you have something called as pop and remove. So to delete elements from list, we use pop and remove. What is difference between them? So let me show you. So when I say L2 dot pop, what do you see?
Self and index.
Yes, so self I said to ignore, right? So index means it's asking for the position, which element, which position element you want to remove, isn't it?
Mm-hmm.
So pop uses index. It takes index. And now when I say remove, see, what does it take?
Value.
Value, correct? So here this is taking value. So if you want to remove a particular value, then we should use remove. When you want to remove an element from a given position, you should use index. So for example, okay, I will say print remove 20 from the list. Now, when I say remove 20 from the list, it means like saying L2 dot remove,
Of 20.
right, of 20, right? And now when I run, what happens? Okay, you get none. You get none because this has removed it. But when you try
Mm-hmm.
to print it, so the end process does not return anything. So what you should do, you should put it like this, and then you print L2. That's what I've been doing like that here. Okay. Your remove is not part of print. So it's not going to print it as such. It will remove it. Okay, but it's not going to print. For print, you have to print L2 after the work is done. So here work is done. Now you can print here. So see 20 is gone. Now,
Okay.
now when I say L2 dot index and I say index 3, that means fourth element in the list is deleted. So print, okay, L2 dot pop. Okay, fourth element means third index, right? Oh, already we have done it, sorry.
Mm.
Okay, so now we'll print it. Removing fourth element. So which is the fourth element here?
6.
5.
5.
Index 3, element fourth is 5, right?
Yeah.
So when you run it, what happens? 1, 2, 3, 4. Oh, I said index.
Instead of
Put
pop.
it pop, yeah.
And that's what I was thinking.
Yes. So now your 5 is gone.
Okay.
Okay, so you can add an element at the back, okay, at the rear of the list or anywhere in the list. Remove element based on its value. Now say, I'm saying 20, right? List can have more than 20. I mean, more than one 20s.
Mm-hmm.
So if I say 20, 20, 23 20s, and if I try to remove, which one will be removed?
All 3?
No, first occurrence. So it removes only one value at a time. Okay. So if you have multiple values, only the first value will be removed, not all the values.
Okay.
Only the first value is removed. All right.
Mm. Yes.
Okay. So uh, we have, okay, so there are couple of more functions which I want to do. Okay,
Mm.
so you have okay, you have clear. Clear will delete all the values. Okay, so I'll do it at the end and clear to remove all the values. Now your list will remain. Okay, so when I say L2 dot clear, so L2 after clear, your L2 is there. It's not going to say that L2 is gone.
Okay.
Okay, so but it will have blank, no values here. You see,
Okay.
if you want to delete the variable, then we use a function called del. Now, del can be used for anything, integer, float, any variable, you can say del. Del L2. Now, when I say del L2, now if I try to say print after delete, if I say L2, it will say L2 is not found, L2 is not defined because you have deleted it. Del
Okay.
means, okay, that variable no longer exists. So when you use multiple variables, okay, in your program, and then what happens, because you'll be creating order, new ones for new work, and let's say you're not using the old one. So it will be
Mhm.
in the memory, right?
Okay.
It will be in memory in the, and that will take your space in the memory. So if you're sure that you're not going to use any variable, it's a best practice that you delete it. Not compulsory, but it is best practice so that that thing is gone from the memory, right? So let's say if I tell you, okay, forget whatever we have done for last 1 hour. So it's like deleting whatever we have done. Okay, so
Yeah.
something like that. So you're deleting your memory. You're deleting your memory. So this is like you're deleting the element from the memory so that it occupies less space in the memory.
Okay.
Okay, so this is your uh, okay del function. Okay, but before this, I want to talk about two more stuff, which is called as sort and reverse. Okay, or let me do reverse first, so then we'll do sort. So if I say here L2 dot reverse, so the elements in the list L2 after reverse will completely get reverted or reversed. So you see, it was 4, 3, 8, 6, 10, 10, 6, 8, 3, 4, 10, 6, 8, 3, 4. So elements in the list will be reversed. When you say sort, so L2 dot sort, okay?
Increasing.
Yes. So default is increasing order. So now when you print L2 after sort, okay, you get L2. Okay, so now you see it is 3, 4, 6, 8, 10 got sorted in increasing order. Now,
Okay.
if you have to sort in decreasing order,
Sort of reverse.
so yes, so you can do sort and then reverse, or you can do together. How? L2 dot sort, okay, and in the bracket you say reverse equal to true.
Okay.
Okay, sorting in reverse order. So it's like you are doing sort and then reversing it. So you say sort reverse order. So sorting in reverse order, which is decreasing order.
Okay.
So now when you say print list after reverse sorting, okay, and you say here L2. Now when you run it, so 10, 8, 6, 4, 3. Okay.
Mhm.
There's one last stuff and then we will end our discussion. Okay. So listen carefully. This is important.
Mhm.
Okay. So there's difference between what is called as copy and extend. Okay. Let's do first extend. So extend is like adding, but it's like saying L2 equal to L2 plus L3. Okay. You can do like this. See, we have done L2 equal to L1 plus L3, something like that we have done,
Yeah.
right? We were using a different way. But when you're using extend, it's like you're adding existing element. Sorry, you're adding new list of elements to the existing list. So
Okay.
L2 equal to L2 plus L3. So L3 data will be added to L2, correct?
Okay.
Same thing, we are doing it extend. Okay, instead of doing L2 equal to L2 plus L3, we can simply say L2 dot extend. Okay, so let's say here you have L3 equal to, okay, 10, 30, 20, right? And now what I say, I'll say L2 dot extend L3. Okay, L2
Okay.
dot extend and L3. Now if you print L2 after extend and you say L2. Okay, so you have, okay, these are from your L2 sorted in decreasing order, and then you added 10, 30, 20 to it.
Okay.
Okay. Then we also have something called as copy and equal to. Okay. So this is your L2. This is our L2, correct?
Yeah.
Now what I do is I'll say L5 equal to L2, and I'll say L6 equal to L2 dot copy. Now both are used to copy elements from L2 to new list. So
L6.
yeah, so if I say print 1 L2 equal to L2, and then I'll go ahead and I will add L3, L2, okay, this is L5 and this is L6, right? So I'm going to say L5, L6. Okay, now when you print it, your L2, L5, L6 all has to be same, right? We did copy.
Yeah.
Okay,
Okay.
right? All have to be same.
Okay.
Correct?
Yes.
Any questions so far here?
No.
Okay, now let's see this. Now, what I'll do here, okay, okay. Now let me add some elements to all the three. L2 dot append 77, L5 dot append 88, L6 dot append 99. Okay. Now again we will print and see the difference between the output. So I should make it as 1, 1. I'll call it as 2, 2. So 2 is after these changes. I added one element to each of the three lists that we have, 2, 5, and 6. So
Yeah.
your 1 will be same, right? That's what we saw. 1 will be same, right? All values the same. Now you
Okay.
see this and tell me, what do you notice?
But the 77 and 88 are only printed in L2 and L5.
So what does that mean?
It means, what does it mean? L6 is not equal. equal to L2. Wait, can you scroll a little bit up?
Let me do. Right? You have everything.
I wonder why. Because we use the copy function only for L6.
So what do you notice?
Isn't, isn't it the same? The print too, they're the same except for the twos.
Hmm?
Seventy-seven, 88. Okay, did L6 only carry the beginning values of the L2? Um, mm, Hello?
Yeah.
Yeah, so I think it's because you said that we can equate two lists and we can like create one, a single list. And because L2 is equals to L5, they carried the same values. And even if we said append two values, they carried it on. But since we said L6 is L2 dot copy of, so it only copied the primary values of L2 and only appended 99. Because L5 is equals to L2 is not equals to L6. Is that right? Or am I missing something?
Okay, good try. Good try. Okay, so what happened here is if you look at L2 and L5, they behave like as if they are same. We added 72 to L2, it got added to 75. Sorry, when we added 77 to L2, it also got added to L5. When
Yeah.
we added 88 to L5, it also got added to L2. So when you say equal to, okay, when you say equal to, they mean the same. We call this as shallow copy. Okay, they
Mhm.
are pointing to each other. It's like giving one set of values having two names. Okay, and
Yeah.
this is where it creates a duplicate copy. So that's why L6 we added a 99 and L6 only has 99. It has no relation to 77 and 88. So when you
Oh.
want to create a totally different copy, when you want to create a totally different copy, then you use comma. But if you want to create a copy, which probably doesn't make sense, I have not used much, but that's a feature which is there. Okay, if you want to, rename and it's like, your brother and sister having same address. So L2, like if I ask what is the address of L2, give you same address, and what is the address of your brother, it will be same address,
Yeah.
right? So it's like to having same address. So whether you ask what is the value of L2 or you ask value of L5, you'll get same thing. Okay, but L6 is totally separate. Okay, so with that we come to end of our discussion on list.
Yeah.
Tomorrow we'll do more programs on this.
Sure.